We're going to talk about factors and prime factorization. Do you guys know what a factor is? What's factor? Yes, usually it's a number. Y'all are like, oh, yeah, we know what factors are. Sure, we know what it is. Yeah, what's a factor? And then you all get real quiet.
It's like a multiple of a number?
No, it's not multiple. Factors and multiples are very similar. Whole numbers that are multiplied to find a product are called factors. Those are the factors. 2 times 3. Those two things are the factors. The answer to a multiplication problem is a product. Okay? So we are going to be working with factors for today. We don't need that part. When pairs of factors begin to repeat, then you found all the factors. So what we're going to do is we're going to look for the factors of 16. Now, we need to, there's some vocabulary here that I want to cover for you. First of all, 16 is divisible by, the word divisible means it can be divided evenly by. Okay? So, what are some numbers that you can divide 16 by and get a regular whole number? Okay, so first of all, we can say 8 and 2. So 8 and 2 definitely go together. What else? 1 and 16 definitely go together. And what else? 4 and 4. Now, list all the factors of 1 and 6 of 16. We have 1 and we have 16. We have 2 and we have 8, and then we've got 4. We don't need to write 4 twice. Okay? So I've listed all the factors of 16. And as you can see, and I'm sure you guys have all done this before, made those little upside down rainbows or whatever, things like that. Okay, what's that? Factor rainbows. Awesome. On your whiteboards, I want you guys to list all the factors of 19. So basically, you need to come up with all the numbers when multiplied together equal 19. Yeah, that's it. That's all. Good. 1 and 19. That is all. Though there is no other numbers. There's a special word for numbers that can only be divided by 1 in itself evenly. What is that word? It's a prime number. Okay? Nothing else. You can't divide 19 by anything but 1 and 19 and come up with an even number. Come up with a whole number. That's it. 1 and 19. Prime numbers are important. What are, let's go through. Let's kind of go through the first few of them. Is 1 prime? Obviously, yes, 1 is prime. What about 2? What about the number 2? Who says yes? Raise your hand. Okay, so I'm assuming everyone else says no. 2 is prime. You can't, the only thing that you can multiply together to get 2 is 1 times 2. That's it. That's it. What about 3? Is 3 prime? Yeah, 1 times 3 and nothing else. What about 4? 4 is not prime. What can you multiply together to get 4 besides 1 and 4? 2 and 2. So that means 4 is definitely not prime. What about 5? 5 is prime. Can't multiply anything. What about 6? Once we have reached the point, once we've gone past the number 2, any number that's even is definitely not prime. Because you can always divide it by 2, right? 4 you can divide by 2, 6 you can divide by 2, 8 you can divide by 2, 10 you can divide by 2. So any even number, now that we're beyond this, is definitely not prime. So let's just work down the odds. So 6 is not prime. 7, is 7 prime? Okay. We know 8 is not. What about 9? No, 9 is not. 9 is definitely not prime, because what can you multiply together to get 9? 3 times 3. So 9 is not prime. 10 we know is not. What about 11? Yeah. 12? No, it's even. 13? 13 is prime. 14? No. We're saying yes if we're saying it's prime. Okay? Okay. Okay. So 14 is definitely not prime. 15? Is 15 prime?
No.
No, 15 is not prime, because we can multiply 5 and 3. So we got 17 is going to be the next one. That's prime. 19 is prime. 21? No. 23? Okay. So we could keep going, but I don't really want to. Next problem. Oops. That I want you to do on the whiteboard. I want you guys to list all the factors of 12. So here's how I would attack this. First of all, you guys can do it however you want, but I'm going to start with 1. My choice is I'm going to go 1, obviously 1, and 12. We know that. Then I'm just going to go right down the line. Does 2 go in there? Yeah. 2 and 6. Does 3 go in there? Yeah. 3 and 4. And you know what? I know right then and there I'm done. Because these numbers are close. Okay? 3 times 4. I know that once I start going back the other way, my next number is going to be 4. Now I'm going from here to here. You see what I mean? So once I get to these numbers that are close together, we're done. The other thing is if we get to the halfway point, you know you're done as well. Let's say we were doing the ones up to 36. We would go 1, yes, 2, yes, 3, yes, 4, yes, 5, no, and you just keep going that way. Once you get to 6, you're done, aren't you? Because you got 6 and 6. Otherwise, then you're working back the other way. So once these two numbers get to the point where you're real close, that's it. Okay. So then we need to make a list. 1, 12, 2, and 6. Notice I go to the outside, and then 3, 4. Okay, and there's my answer. Can you guys handle that? Yes.
You have to do it from the outside.
It makes it easier, but you can do it however you want, I guess. All right. The other thing I want to teach you today, or remind you of, because it's things that you have already done before, is prime factorization. Now, it says, first of all, you can use factors to write numbers in a different way. These are all different ways to write 12. 1 times 12, 2 times 6, 3 times 4, 3 times 2 times 2. What is different besides the fact that there's 3 of them from all of these other ones? What's different about this one? All of these numbers are prime. That's called the prime factorization. Does anyone remember how to find prime factorization of a number? Do you remember making factor trees? Factor mountains, is that what you call them? Mountains, trees, whatever, okay? To me, it's all the same. Prime factorization of 24. So here's how you do this, okay? You write 24, and you do this, and you make a Christmas tree, basically, okay? Just in time for the holidays, all right? 24. Give me two numbers, any two numbers besides 1 and 24. Any two numbers that you can multiply together to get 24. 12 and 2. Are either one of those numbers prime? The 2 is prime. So what I do is I circle it. Okay? I want you to get in the habit of when you're making these factor trees, when you get to a prime number, I want you to circle it. Okay, 12 is not prime. Give me two numbers you can multiply together to get 12. 6, what? How about 6 and 2? We're getting 12, right? Is either one of these numbers prime? 2 is prime. 6 is not. How about 3 and 2? It's a lopsided tree. Deal with it. Okay? It doesn't look like a mountain either. It'd be a mountain would fall over and crush people. Okay? Whatever you want, okay? Now, a lot of you are used to being done here. I do not want you to be done here. You are not finished, Parker. You're not done here. We have more to do. It says write the prime factorization. So you need to write this out. 2 times 2 times 2. How many do I have? 1, 2, 3. Okay. Times 3. You are still not quite done. Because you know what I see here? I see 3 of these. So I'm going to write this. 2 to the 3rd power times 3. I'm shortening this up. Now, in previous grades, you guys probably got this far right here and were able to stop. And maybe even last year, Mrs. Redash let you just do this. Okay? But I'm taking it one step further, and this is the kind of answer that I want from you. Okay? I'm just shortening this up. Okay? 2 to the 3rd times 3. These are all prime numbers. Okay? I also want to show you one other thing. Instead of doing 24, do you know that I could have done this? I could have had 24, and instead of going 12 and 2, I could have done what? What's some other things that we could have multiplied together? 6 and 4. Are those numbers, either one of those numbers prime? No, neither one of them are. So we got to break them down again. 2 and 2, all right? So those are good. And 6 is 3 and 2. Is the prime factorization still the same? Are all of the circled numbers the same circled numbers? Yeah, it makes no difference how we decide to break it down. We could do 12 and 2. We could do 6 and 4. We could have done 8 and 3. Those all work. When we get down to the bottom, though, that is all going to end up being the same. So we have, this is going to be 2 to the 3rd power times 3. There's our answer. Did you have a question? Someone had a question? Okay. On your whiteboards, I want you guys to do the prime factorization of 45. Now, 45. Every single one of you did this. Right? It works. No problem. Nothing wrong with that. Could have done that too. Okay? Either way, doesn't matter. Makes no difference. Prime factorization is really easy when you know your multiplication facts. If you don't know your multiplication facts, it's hard. It gets a lot harder. So that's an important skill that you need to have. So I'm going to write this out as 3 to the second times 5. Now, I also want to show you guys something, a mistake. I'm going to do it in red so that you see that it's a mistake. I don't want you to do it, but I saw some of you starting to do this. You got this 45 down, and then you did this. And then you did 9 and 5. And then you did this, 1 and 5. I don't ever want to see a 1 in a factor tree, ever. Don't put 1 there. It doesn't belong. Because if you have to put a 1 in there, that means that the number above it is already prime. Okay? Don't break it down any farther. There should never be a 1 in a factor tree, ever. If you have 1 in there, it means you made a mistake. Okay? Your homework assignment is page 171, 172, 10 to 28 even, and 46 to 50 even. Yes.